4.2, multiplication of polynomials. So last class we looked at polynomials. So today we adding and subtracting. So today we want to expand and look at multiplying with these and see what results from that. Okay. We don't have any definitions here. And so let's just get right into our examples and remember a few of these things. So let's start real simple here, 4x squared times 2x. Okay. Now remember that when we multiply things, here we can multiply numbers and we can multiply same variables. When we do multiply the variables, it's all about the exponents with those, okay? And so we want to pay attention to those. So what happens here, we want to make sure we remember that if an exponent is not shown, that is a power of 1, because that an exponent tells us how many of those that we have. And so I have 1x there. So we first multiply 4 times 2, and that is 8. And then x squared times x, we add the powers. So 2 plus 1 is 3, so I get x to the third. And that is my result. So just by multiplying the coefficients together and then like variables together, we can do that. Okay. All right, so let's start increasing. Say we have 6ab times a plus b. So now I've got multiple letters and I have to distribute. So if that was just a 6, we would multiply it in, right? So we're going to do the same thing here with this. We're going to take this 6ab and we're going to multiply it in. Now, we do need to remember again that we have powers of 1 on all those variables because there's not another power there. All right, so here's 6 times 1, because remember there's also a 1 in front of these. 6 times 1 is 6. A times a, we add the powers. 1 plus 1 is a squared. B times, well, there's no b on that, so it just comes along. All right, so that's just the first one, multiplying 6ab times the a. Now we need to multiply by the b. So plus 6 times 1, again, is 6. A times, well, there's no a there, so it's just a. B times b is b squared. Those are not like terms because the powers are different. That's a squared on one and just an a on the other. So as we discussed last time, that is not a like term. So we're done. Let's look at another one here. 5cd times 3c squared d minus 5cd squared. I'm going to write this one underneath it. So again, we're going to take this 5cd and we're going to distribute it in one at a time here. So 5 times 3 is 15. C, that's a 1 power to 1. So c times c squared, that's c to the third. And then d times d is d squared. Now we need to do 5 times negative 5 is a negative 25. C times c is c squared. D times d squared is d to the third. Now again, our powers on each individual piece is different. So this is my final piece. Okay. All right, let's keep moving up in size here. So now we want to look at the binomial. So 2x plus 9 times another binomial, x plus 2, right? Now, there are many different ways to multiply these. There's what's called the FOIL method. There's also called the box method. And there may be even an X method or something like that. I use FOIL, so that's what I'm going to teach here. But if you use the box method and show your work, then you're fine with that as well, okay? All right, so to use FOIL, we're going to distribute here. So we're going to take 2x times x. Well, that's 2x squared. 2x times 2 is 4x. Now we go to the 9. 9 times x is 9x. 9 times 2 is 18. So essentially, I'm distributing everything in the first one to everything in the second one for those, okay? But now I need to see, do I have any like terms? Sometimes I will, sometimes I won't. So here, I've got a 2x squared. Here I've got a 4x and a 9x. So 4 plus 9 is 13x. And then we have this 18. And that is our final answer. You must combine like terms because our instructions are to simplify with each species. So always multiply and then simplify afterwards if you can. All right, let's do a couple more of these because they're going to be playing a major role for the rest of the class, rest of the semester. Okay. So 5x plus 2 times 3x minus 1. All right, so again, if you want to draw the arrows, you can. You don't have to. So I'm not going to draw the arrows anymore. I'm just going to point and tell what I'm doing. So 5x times 3x is 15x squared. 5x times negative 1 is a negative 5x. 2 times 3x is 6x. 2 times negative 1 is a negative 2. Now again, I can see in the middle here, which is typically if you're going to have a like term where it's going to be, not a guarantee, but that's probably where it's going to be. We can combine those. So 15x squared, negative 5 plus 6 is a negative 1x, or just negative x, and then minus 2. Right. Number 6. X squared minus 3 times x plus 1. All right, so again, it's still a binomial. Same process. Nothing is changing here. X squared times x. Well, that's going to give me x to the third this time. X squared times 1 is x squared. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. However, this time when I look at those, there are no like terms. All my powers are different. So since there are no like terms, that is my result. All right, number 7. X plus y times 2x minus y. So this is to show that we can have multiple letters. So x times 2x is 2x squared. X times negative y is negative xy. Now the order on that doesn't matter. If you put y then x, it's fine. I'm typically going to put it in alphabetical order, so I'll put x first on those. Y times 2x is a 2xy, or again, yx. And then y times negative y is a negative y squared. We do have like terms here. Now, even if you write one as xy and the other one is yx, they are like terms. They still have the same variables with the exact same power. So it doesn't matter, the order is different as long as it's the same variables with the same power. So we get 2x squared. So negative 1 plus 2 is a positive 1 xy, and then minus y squared. Those are not like terms, so that's how we know we're done. All right, just a few more here. So number 8. Now they're going to start looking a little bit different. So let's start here with this one. So x minus 5 squared. One of the things that we have to remember about a power is that a power means we write it twice. Whatever's inside, we write it twice and then multiply. And that's very important here. You need to do that. You need to write this as x minus 5 times x minus 5. because our result is going to end up different than what you may think. Right now, if you're looking at the top, you may think that your answer is going to end up being x squared minus 25 or x squared plus 25. But that is not the case. And so we're going to see why right now. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. We have like terms. Negative 5 minus 5 is a negative 10x plus 25. So we can see that we end up with a trinomial as our final answer. Okay, so I highly, highly recommend you write that down so that you know that you're doing the problem correctly. Okay. Right, our next one. Now we're going to start getting a little bit bigger. X minus 4 times x squared plus 4x plus 16. Now, as long as one of my polynomials there is a binomial, 2, so x minus 4 there, that has 2 terms in it, I'm still going to use FOIL method. I'm still going to just distribute and write it down. Okay, so that's what I'm going to do here for those. So x times x squared, x to the third, x times 4x, that is 4x squared. X times 16 is 16x. So we've done all of that first one by distributing in. Now I'll move to the second one. So negative 4 times x squared is negative 4x squared. Negative 4 times positive 4x is a negative 16x. And then negative 4 times 16 is a negative 64. Okay, so we just have a little bit more to do. So now we look for our like terms. Now, one of the good things we notice that if we have opposites, they kill each other. These kill each other because they're opposite numbers. They're going to make 0. And so I'm left with x to the third minus 64 in this case. Now, that's not always going to happen. It may happen, but I'm not guaranteeing that you're going to cross out half your problem on these every time. Okay, so make sure you're combining the like terms properly. And if they go away, fine. But it's not a guarantee that that will happen. Okay. My last one, pretend here. Two x plus 3y plus 4 times 2x plus 3y minus 4. So this is a trinomial times a trinomial. Tri means 3 with them. Okay. Now, if you would like, you can do FOIL method. I'm not going to do it this time. I'm going to do a different method. The reason why I don't do FOIL and draw my arrows is the first one's fine, the second one's fine, but that last one I'm going to have to draw arrows that's going to overlap and get confusing. What am I looking at? All those pieces. And so I don't really like to do that for those. So I'm going to show you the box method here on this one, just because it's so big, it may clean things up for us. Excuse me. So 2x plus 3y plus 4. So notice I wrote that on there. I left a little bit of gap between those. And then along the side of here, I'm going to write 2x plus 3y minus 4 from the other one. We're going to make boxes because it's a box method, right? And in between each one of these. And now we're going to fill in the box by multiplying what corresponds with that box. And so here, I've got 2x and 2x converge right there. So 2x times 2x is 4x squared. 2x times 3y is 6xy. 2x times 4 is 8x. Now I'm just going to move down. 3y times 2x is 6xy. 3y times 3y is 9y squared. 3y times 4 is 12y. And then finally move to the last one. So negative 4 times 2x is a negative 8x. Negative 4 times 3y is a negative 12y. And negative 4 times positive 4 is a negative 16. So now we just need to put all of that together, okay? Now I do recognize, now I see a negative 8x and a positive 8x. Those kill each other. Negative 12y and a positive 12y, those kill each other. And a lot of times what you will find is that on these kind of diagonals is our like terms. Notice the 8x is one the same, the 12x is one the same diagonal. I'm not going to guarantee that. I've never proven that mathematically, but it is a possibility, and that's where you may look first. So now let's go through, we'll check off. So 4x squared, that's the only x squared. So 4x squared, so that one's done. We have a 6xy and a 6xy. It's be 12xy. That one's gone. So 9y squared, and that's the only y squared. And then finally, negative 16 down here. And that is our final answer. Okay. Now, again, if you want to use the FOIL, kind of putting your arrows or distributing out, go for it. It's just to allow them all out. That's okay. Or you can use this box method here on those. Okay. But you want to make sure that you have this multiplication down. We'll be doing a lot of it from here on out for the rest of the semester. So you want to be able to make sure you can do these pieces and do it efficiently. All right. So that's going to be it for 4.2.